basics of limits are very important. So today I will make you understand. So my name is Chikhar, and for more such I teach maths, and for more such new topics you can subscribe to my channel. Okay, so let's start. Okay, so limits. Okay, now before this, let us understand about indeterminate forms. Okay, what are the indeterminate forms? Now the word itself says the forms which are indeterminate, which we cannot determine by seeing them or by looking them. We cannot determine what the value they will give us. Let us see 0 by 0, infinity by infinity, infinity minus infinity, and there are some more such indeterminate forms. Okay, these are called indeterminate forms. Why? Let me explain you. See, 0 by 0. Okay, now you know that 0 by any value will give you 0, right? And any value by 0 will give you infinity, and also any value by any value x by x will give you 1, right? So x by x will give you 1, any value by any value will give you 1, 0 by any value will give you 0, x by 0 will give you infinity. Okay, so we got 3 different values. Now if you look at this form, you will see that this is applicable to all these cases. Let us talk about this. So let us say we have 0 by any value, and instead of that any value we have 0 again. Okay, so we can say it will give 0. Let us say instead of any value we have 0 divided by 0. Okay, this case, so it will give infinity. And let us say we have two any values. Okay, any value divided by same value will give you 1. Okay, so 0 by 0 should return 1. Okay, so now see, this form can return 0, this form can also return 1, this form can also return infinity. Okay, so this is the reason why these forms are called as indeterminate forms. Okay, because by looking at them we cannot say okay, what is the right answer for these indeterminate forms. Okay, so also with this infinity by infinity, infinity minus infinity, there are some more such indeterminate forms, but here in 11th you will mainly come across this form. Okay, so now you understood what is indeterminate forms. Okay, now let us go further towards limit, concept of limit. Okay, now see, what was the need to find this new concept. Okay, maths was going very well up to now. What such problem did mathematician find? So they found this new, they introduced new topic. So what was limitation till now? I will make you understand. See, let us see, we have function f of x square minus 1 upon x minus 1. Okay, now let us check this function from minus 1 for 0, for 1, and for 2, and for minus 2 as well. Okay, so for minus 2, minus 2 square minus 1 upon minus 2 minus 1, this will give 4 minus 1, which is 3, and minus 3, so this will give minus 1. Okay, so it has given answer minus 1 for minus 2, minus 1 square minus 1, minus 1 minus 1, so minus 1 minus 1, minus 2 by minus 2, so it has given us answer 1. For 0 minus 1 divided by 0 minus 1, minus 1 by minus 1, so again it has given 1. Let us check for 1 1 square minus 1 upon 1 minus 1. Now see, here it is 0 upon 0. So here we got indeterminate form. Okay. Here we got indeterminate form. Okay, so for 1 it has given us indeterminate form. Okay, so now see, this function worked for -2, for -1, for 0 and for 2, but it did not work for 1. Okay, so it is not like that this function is invalid. The function is valid. Okay, but here the problem is we are not getting directly the answer for 1. Okay, by putting directly 1 into this function we are not getting the answer. Okay, because we are getting indeterminate form, so we have to do something ahead. We have to find new concept how to deal with these types of functions. Okay, so for this, now see what they thought, what those mathematicians thought. Now see, if you look at number line, this is 0, 1, 2, 3, -1, -2 and -3. Okay, so this function work for -2, function work for -1, work for 0, also work for 2, and it will also work for 3, and likewise. Okay, but it is not working for 1. Working in the sense it is not giving us a direct value or direct answer. Okay, because it is in indeterminate form. Okay, so what they thought is, if it is giving for 0 and 2, so also it can give for 0.5, also it can give for 1.5. Okay, so in this manner, let us say, okay, we cannot directly find for 1, so what we will do now is we will check the answer of this function for the values which are near to the 1. Okay, now see, from left side the very near value to the 1 is 0.9. okay, and from right side it's 1.1. okay, so what they thought was, by finding values of these two, we can approximate the value for 1. Okay, by putting 1 directly in this function we cannot say, because it is getting us indeterminate form, but by putting nearby values we can approximate what it will give for 1. Okay, so now let's see, let us say we have for f of say, let us say for f of 9. Okay, for f of 0.9 -1, 0.9 -1. Now this you can check, it will give value 1.9. okay, also for 1.1, okay, it will give value 2.1. okay, now this you can check by calculating. Okay, so now see, from left side it has given us 1.9, from right side it has given us 2.9. now from these two values we got an idea, or an approximate idea, that if we will put 1, of course it is giving us indeterminate form, but for 1 the answer could be 2. Why? Because it is between these 2 points, right? Okay, this is an approximate estimation, but if we further check the answer of this function for more nearby values to the 1, then we will get this approximation will recede. Okay, we will get more closer value, more actual values. Okay, see, we have checked for 1.9, we check for 1.1. okay, and what is more close value to the 1 than 1.9? Of course 1.99, right? Similarly, more near value to the 1 is 1.999, right? From right side 1.01 is more near than this, and 1.001 is more even near than this. Okay, likewise. So from this, of course, this function will give some values for these values. Okay, it is only not giving us the value or direct answer for 1, but it will give you for these values. Okay, so by getting values near to the 1 from left side and from right side, you can approximate the answer of this function for 1. Okay, and this is what the actual concept of limit is. Okay, this is what actually limit is. Now see, so how do we write this? Now from say, if you will find the values of these all values, then you will get more close and close values to the 2c. Here you got 2.1. For this I think you will get 2.01. For this you will get 2.001. For this, sorry, for this you will get 2.99, 1.99. For this you will get 1.999. Okay, for this you got 2.1. For this you will get 2.01. For this you will get 2.001. So what indicates is these values are going nearby to. Okay, so this is our answer for all these values. So from this we can determine the value for 1. So now let us see how limit works. I hope you understood, okay, the necessity of this concept. What was the necessity for this new concept? Okay, this concept came because some of functions were giving us indeterminate forms, so we were unable to directly determine the answer or the values. So we found out a different logic or different idea. Okay, now say limits. So how do we symbolize this thing is limit? We write it as limit. Okay, in short form, x tends to 1. Okay, in this case this is symbolical form. Okay, how we write. Now what was our function f of x? Okay, so see, for those values, for 2, for 3, this function is directly valid. That means it gives us direct value, but for 1 it did not work directly. So we got a new concept called as limit. Okay, so now for 1, how we write this? So limit x tends to 1 or x approaches 1. Okay, f of x. So limit x tends to 1. What was f of x? Minus 1 upon x minus 1. Now see, what x tends to 1 or what x approaches 1 means, here we are not putting x, we are not putting 1 directly at the place of x, but x will tend to 1. That means the values of x will, from left side, they will tend to, sorry, from left side they will tend to 1 like this. Okay, so it is not directly 1, but this value is tending to 1, right? From right side also it will tend to 1. Okay, see, now why this tending? Because if we put direct 1, so it will give us indeterminate form, and we do not want indeterminate form. So x will tend to 1. It will not be exactly 1, but it will tend to 1. Okay, this is what this symbol means. Okay, so now in this function, in this limit, x is tending to 1. Now see what you can do. Okay, so here, now this is symbolical way how you can write this function. X tends to 1, x square. Okay, but still now we have to put 1 here, but still we cannot put directly 1 here. So what we will do is, we will change this function somehow. We will not change, but we will substitute these functions somehow in order to avoid indeterminate form. Okay, this form we will avoid this form. Okay, so how you will avoid? Now see, you can write x minus 1, x plus 1 upon x minus 1. Okay, this will get cancelled. X plus 1, and this is same as this. So now what you can write? Limit x tends to 1 for x plus 1 is, so see, now we do not have any indeterminate form. Now this will not give any indeterminate form, so we can directly put the value 1 here plus 1, which is giving 2. Okay, so what it does tell is, for this function we are x is tending to 1. Okay, we are just showing that we are putting directly here 1, but actual why we are writing this symbol, this indicates that x tends to 1. Okay, we are not putting directly 1, this is just to show. Okay, we will get answer 2, but actual meaning is x is tending to 1. Okay, because if we put directly, then we will get indeterminate form, which is not valid. Okay, so this is how you represent the limits. Okay, limit x tends to 1 for these two. Okay, so I hope you understood why, for what they got this new topic, how to represent it. Okay, and how can we eliminate that earlier problem. Fine, so mathematicians were able to eliminate those problems, okay, by these concept limits. So now further we will discuss, okay, in next videos about its further explanations of limits, and we have more like in ahead videos we have more like derivatives and all those things, so we will try to discuss all those. I hope you understood this. So thank you, and tell me, you can comment down if you have any doubt related to this topic. So thank you.